Hey everyone, Geophysicist Stefan Burns here. There has just been, in the past 12 hours, a magnitude 6 earthquake that struck the big island of Hawaii on the western side, just south of Kailua Kona, and just even a little bit further south than Captain Cook. This was a big earthquake. It's about 22 kilometers down below the surface. So there's always a connection to volcanism when you get anything basically happening on Hawaii, because it's a giant volcanic system connected to the Hawaiian hotspot, the mantle plume. It's the biggest hotspot mantle plume on the planet. I mean, there's some others that are right up there as well, but this is one of the big boys. It's been around for tens of millions of years, a very, very long time. And the idea with this earthquake, because of the depth that it occurred, the location, is that just the simple sheer weight of this volcanic island on top of this relatively thin oceanic crust caused there to be a rupture, and that earthquake energy spread out. What's remarkable about this, and here we have a report from someone on the ground. I also texted a couple friends, they got back to me, but first ever earthquake I experienced on the Big Island, just north of the epicenter. So she's right in that Kailua Kona region. Terrifying, stuff broken, falling off the walls, unable to stand during. That's what my other friend Sheila, who may be watching, also reported. She's right in that area, actually a little bit further south. And she said that she was shaken up for about 15 minutes afterwards, just because it was such an intense jolt. Some other people, before the live stream got started, they commented on that. People on the Big Island experienced about 15 to 20 seconds of shaking, but this was also felt elsewhere. So you look over here, this is our USGS, like, did you feel it responses at the 1 kilometer scale. You see a lot of responses here on Maui, all the islands. Here's Oahu, tons of people felt it in Oahu. And even a response on the forbidden island of Niihau, which there's almost no one there. That's super far away from the Big Island. Tons of responses from Kauai. This is a magnitude 6. They've had up to magnitude, effectively magnitude 8 earthquakes there. There have been 2 magnitude 7.9s in the historic record. This would be 1975 and 1868. Think about that, magnitude 7.9 earthquakes. So Hawaii gets big earthquakes. This is the first magnitude 6 though since I believe 2021. And the last big earthquake was a magnitude 6.9 May 4th of 2018. That struck a day after you started to get a big rift fissure eruption in Leilani Estates. We see the aftermath of that there, scarred upon the landscape. So most people that felt this only felt moderate, like light to maybe moderate shaking. Here we see our intensity there. So if you see any of these colors in the blue to green zone, obviously it's an earthquake and you're like, what the heck is happening? But it's nothing terribly scary. But for the people that were here on the west side of the Big Island, you have yellow, you have orange responses. It was an intense earthquake. Apologies, I'm getting over a cold, so hopefully I won't have to cough too much or sneeze or any of this stuff. But this was felt all across the island, likely caused just from the sheer weight of the Big Island on the thin oceanic crust. But the thing to keep in mind is that generated a big shock wave. And well, you have a very extensive, widespread, magmatic, volcanic plumbing system that exists due to the hotspot and mantle plume underneath the Big Island. Also underneath Maui. We do still have an active volcano there in Maui. It's the least active in some sense, the fact that it's the furthest away from the hotspot. You have the big ones here on the Big Island would be Mauna Loa, Mauna Kea, Kilauea. Kilauea being the most active, but Mauna Loa obviously being the big baddie. Mauna Kea has an active magma reservoir, but it's a little bit more disconnected from the superactive plumbing system. And it's probably going to erupt again in the future. Who knows when, though? It could be 500 years. It could be 50 years. It could be 5 years. Maui is even further away. So this shock wave hit all of that. And in fact, if you look at the data from the USGS, here we have our tilt meter data for Kilauea. This is how we keep track of the ongoing eruptions at Kilauea. There's been 47 now. Is that we see this big spike in the tilt data. And here we see that on the weekly scale. There's that big spike. We've picked up other earthquakes before with these tilt meters. Here we see the monthly scale. Big spike. Interesting to note how you notice that inflation suddenly changed immediately after that earthquake. So the inflation rate changed. Now this earthquake, again, it was an oblique reverse thrust earthquake, and I'll explain that a little bit more later, which is actually kind of odd. If you're considering like overbearing weight on the oceanic plate, you would maybe expect a little bit of extension. Instead, you had the crust actually slip up a little bit like this, but it also went to the side. So it's this oblique reverse thrust earthquake like that. That's a little bizarre. So that, perhaps could be related to some larger push of energy coming up from the surface, causing it to have that slip that actually compresses everything, right? That's a compressional movement on the whole for the plate, rather than it being extensional, because maybe you get this weight pushing down on it and then it extends outwards as a response. That's not what occurred. It is a reverse thrust oblique earthquake. So a lot of the energy went off to the side, but there was movement of the earth at that fault line over the other earth below it. But that shock wave effectively hitting all the magma reservoirs and sills and dikes and the crystal mush zones and everything existing under Hawaii. And we've seen many, many times now that when an earthquake passes through these intricate magma systems, the reservoir and plumbing systems, that often leads to volcanic activity. Case in point was the magnitude 8.8 that struck last year, July 29, 2025, in Kamchatka, off the coast. You immediately had a volcano, Krashenikov, which had been slumbering for 600 years, become active, and it's still active right now to this day. 600 years, dormant, quiet, huge megaquake shockwave, clearly woke it up. You had Shiveluch volcano start to go nuts. You had others like Kraseni, I think it's Kraseni volcano, Benioff. Anyways, there's a whole bunch there, and they're kind of like alternating with their activity, but definitely a big surge of volcanic activity, Kamchatka, Russia, after the megaquake. Well, today, past 12 hours, this occurred at 9:46 p.m. on the 22nd of May, local time for Hawaii, UTC -10. So what's interesting about this, and we're going to cover everything. I also just released about an 8.5-minute clip on my clips channel, Stefan Burns clips. That's really fantastic because I go into how we may be entering into a volcanic supercycle. And by supercycle, I mean like at a century-long time scale. Because going from 1983 to 2018, you had the Pu'u'o'o eruption, and that was the most voluminous and basically like the biggest eruptive cycle that Kilauea had in 200 plus years. Some estimates are like 500 years. Clearly a big event. Well, almost like Goddess Pele, the lava goddess, right, is commemorating what just occurred. We've had 47 eruptive episodes now from Kilauea with this most recent eruptive cycle, which is the Halema Uma'u eruptive cycle starting December 2024. And that occurred, these 47 fountaining episodes, and we can look at some of this footage right here. It's really fascinating. You guys have seen this. I live stream these all the time. The next one's coming up in just a day or two, like probably within less than a week. We'll get episode 48. There's been 47 of these to varying heights, 500 feet above the ground, 1,700 feet above the ground, huge lava fountains. They occurred nearly twice as fast as the 47 lava fountain episodes that occur for the Pu'u'o'o eruptive cycle. And again, overall, going from 1983 to 2018, 2018 being the Big Bang where we had that magnitude 6.9, we had the huge rift fissure eruption in the Leilani Estates, that really was a climax for that, that being the most active, the most activity we've seen from Kilauea in 200 plus years. Now we've reached that benchmark of 47 lava fountain eruptions, which is how many the Pu'u'o'o eruption had from 83 to 86 in nearly half the time. So there's clearly something's happening. So I'll link that video. It's really concise. That's one that you can share with friends. I mean, you obviously share this with friends as well. Hello and welcome, everyone. I'm your host, Stefan Burns, geologist, geophysicist, someone who just loves Hawaii, has been there many times. It may end up being the final destination. We'll see. But there's a lot of beautiful people that live there. Tons of fans of the channel live there. We'll get to some of your comments of like what you experienced and what you felt later on in the video. But because it's such an active area geologically, I think it's one of these premier places to learn about the Earth from an earthquake perspective, from a volcanic perspective, and from a plate tectonic perspective. Also, in some aspects, from a larger perspective in terms of the sun and the stars and the cosmos. There's a lot of really rich history. Hawaiian culture has their own entire star map and constellations. It's really cool. And we see volcanic rhythms being linked up with solar cycle rhythms. And this is some research that's been done by many people, but one paper came out in 1989 linking rhythms of volcanic activity, solar activity, and they identified this cycle of about 10.5 to 11 years, this peak. We'll look at some of this data. For example, I have it right here. So we'll look at some of this data more in depth in the video. See, we see this intermediate cycle there. Well, I crunched the data for Hawaii and boom, it popped right out. That's why I'm mentioning this. So there is this link also to the sun. We'll discuss that in addition to everything else. But let's get back to our USGS data. Here we have our latest earthquakes, in fact. And we see the magnitude 6 there. We've had some other earthquakes pop off all around. A clear example of how this energy propagating out has just basically tripped a few other minor faults or fracture zones to have their own earthquake. Because this is a good amount of earthquakes for the day. No big aftershock yet, though. A magnitude 6, would you expect, have a magnitude 5 aftershock? Now that depends on the geologic setting and more, but in general, we could be looking at a magnitude 5 aftershock. I'm not getting the biggest sense that there will be one. I think it may be more of an isolated event. Because the only big we're only getting magnitude, there's a magnitude 4 right there. There's a magnitude 4. But I'm seeing magnitude 3, magnitude 2s, 3.2, 3.2. So I'm not going to be surprised if there's a magnitude 5, but I'm not necessarily, it's guaranteed to happen. The USGS probability for it, if you were to click this, and I don't take this too seriously because they're showing that their aftershock forecast is 2% for magnitude 5. It's higher than that, but it's not 100%. Let's just say that. And this could be a foreshock. Could be a foreshock. I don't think it is probably, but it's certainly possible, so we can keep that in mind. Here we see our moment tensor plot. These things are crazy, but there's kind of just a couple ways to read this quickly. You have two different solutions because based off of the energy coming in, you're presented with two solutions, and one of them is going to be correct. And if you know the actual fault plane geometry in the area, then you can effectively throw one out the window because it's going to be perpendicular to the one that it is. Here, maybe some ultra expert of these fault systems under Hawaii knows which fault plane solution it is, but they probably don't because there's really not that many of these earthquakes that occur. The reoccurrence interval for magnitude 6 or greater earthquakes for Hawaii going back to the year 1900 is about 1 every 6.7 years, roughly. So they occur about 1 every 6 to 7 years. So they occur fairly regularly, but we don't have the best understanding of some of these faults that exist deep under the island in the oceanic crust and even at that boundary in the asthenosphere. Because oceanic crust isn't that thick. It's like 10 kilometers thick, maybe 15 kilometers thick. You get the gist. So you're actually slightly below the oceanic crust. So which of these fault plane solutions it is, I don't know. But we see this is the rake. This third number there is the rake. And that is telling you effectively the movement, the vertical movement, or if it's horizontal movement. So if it's 0 or 180, you have strike slip movement like this, where they just grind past each other. If you have a positive rake, then you have this reverse thrusting motion where you have compression overall, and you have one block moving over the other. And we see there that the rake on this solution is 70. So 90, for example, would be a perfect vertical movement up. So with it being 70, that means that there was 70% movement up, 20% off to the side. That'd be an oblique reverse thrust. Here it's 125. So that's showing that there was, 35%, like not 35%, but a little bit of deviation, more so than that solution in terms of its oblique kind of slip. Regardless, they're both showing it was an oblique reverse thrust. We see here the second number is the dip angle. So one of the solutions has that dipping quite steeply at 64 degrees. The other one's a little bit shallower at 33 degrees. And then this number right there is the strike. So what was the direction of the fault plane? So regardless, if we look at these numbers here, we're looking at something that was, dipping about moderate, like 45 degrees, kind of intermediate. And it was not only going up and compressing everything, but also going off to the side. That's what this moment tensor is telling us. So if we go back here, this was a big earthquake, quite a bit of shaking. One of the main areas, actually let's go here. One of the main areas to watch, and I've talked about this a few times now, is Pahala, where there's an ongoing earthquake swarm since we had the end of the Pu'u'o'o eruptive cycle. So, and 1 second here. I want to get myself in focus. Does that look good? That about does it. Okay. We've had this ongoing earthquake swarm there in Pahala, and these earthquakes are going from about 30 to 50 kilometers down. There's effectively these horizontal sills that exist that keep fracturing open and widening, and magma keeps filling them in. I'm sure there was some sort of sill network that existed there beforehand, but it's dramatically increased since 2018 effectively, because there's been tens of thousands of earthquakes there. And before, you didn't really have that. There were some other earthquake bursts that existed over longer durations decades ago, but this by far is the most significant earthquake swarm that struck this region since recording has begun. Of course, the geologic history of this is very, very long. So maybe it's reactivating this area, right? Refracturing it open, because you're going to have things compress over time, lock up, get closed, magma solidify, cool, etc. So this area, about 30 to 50 kilometers below the surface, connects Kilauea and also Mauna Loa together. And when we see activity like that, it's effectively saying at any point, magma is stored now in this horizontal sill network, which has multiple layers, but two main zones. They can be like 300 meters in height. And they're also separated. These horizontal sills are separated by like 500 meters, a kilometer or so. So it's very extensive. If you get a big enough push of magma coming up from the hotspot, that could then feed now a bigger eruption to Mauna Loa or Kilauea. This isn't really connected, as far as we know, to Mauna Kea. There's also a seamount off the coast, which is the latest expression of the hotspot. That's over here. I'm not sure it's connected into them. I don't think it is. The two main dominant spots right now are Kilauea and Mauna Loa. Though as the plate moves, right, due to plate tectonics, eventually you'll get a new island to form. But this is 2-3 million years from now, something like that. For reference, this is the oldest part of the island there, the least at risk for volcanic eruptions or anything like that. And we're talking ages of like 600, 700,000 years. So it gives you a sense of the movement. So this is taking millions of years to move across, create islands. But this shock wave from here, it's not that far away from Pahala, as you can see. And basically all the plumbing in this area. So let's say it was, and actually let me go back on this and let's read specifically the technical, let's just go to overview, I guess. The tectonic summary. Let's just read what the USGS says here. The May 23rd, 2026 magnitude 6.0 earthquake occurred due to oblique reverse faulting at a depth of 22 kilometers or 14 miles. Large magnitude earthquakes in Hawaii that occur at this depth are typically caused by a lithospheric flexure due to the weight of the Hawaiian Islands pressing down on the underlying oceanic plate. Given the depth, location, and the observed typical main shock aftershock behavior, the May 23rd event is not directly related to magmatic processes. You know, and again, it's key word is typically caused by lithospheric flexure. So it's likely not related directly to magmatic processes, but you can't rule that out 100%, okay? Especially because, again, it wasn't extensional. It was this reverse thrust, which is kind of interesting. It's a little bizarre. The island of Hawaii is the youngest island in a chain of volcanoes that stretches about 5,500 kilometers across the northern Pacific Ocean. The island chain results from magma generated by a source deep within the mantle, the Hawaiian hotspot. The ocean crust and lithosphere above the hotspot within the Pacific tectonic plate moves to the northwest with respect to the deep magma source. Over millions of years, new island volcanoes form. Older volcanoes are carried away from the hotspot towards the northwest, erode, and eventually subside beneath sea level. Non-volcanic or non-magmatic Hawaiian earthquakes reflect the long-term accumulation and release of lithospheric stresses rather than short-term processes associated with the motion of magma before or during an eruption. The long-term stresses are partly generated in the crust and mantle by the weight of the volcanic rock that composes the islands. In that sense, most Hawaiian earthquakes not directly associated with eruptions are nonetheless broadly related to volcanic activity. I think that's an important point. Just the context, the overall context here. Moderate magnitude earthquakes are common in Hawaii. In the last 50 years, there have been 36 other earthquakes of magnitude 5 or greater within 100 kilometers of the May 23rd, 2026 event. Hawaii has also experienced larger earthquakes, including the magnitude 7.7 Kalapana earthquake in 1975 and the magnitude 6.7 Kiholo Bay earthquake that caused minor injuries, damaged roads, and damaged roads and at least 1,000 buildings, and triggered landslides that blocked roads on Hawaii. And if you go back one further, magnitude 7.9, 1868. So again, you can get big earthquakes in Hawaii. So it doesn't appear that there was too much damage from this earthquake, thankfully. We can go here and see some of these other earthquake epicenters going from year 1900 to now. We see our latest one right here, the 6.0. This was a 6.3 that struck in 1951 just nearby. Though the depth here is unknown. There may be a moment tensor for this. There isn't. So we can click out of that one. But you see that this area, that specific epicenter is fairly notable in terms of you have a lot of earthquakes here, and then you kind of get this perimeter of earthquakes. As you can see, there's only one other earthquake that was struck in that location. Effectively, it was slightly bigger, 6.3. This is a 6.0. Again, we're only showing magnitude 6s here. But look, sometimes you get, that's a magnitude 6 right here. That's a 6.4 Waimea, right in the smack dab center of the island, effectively. 6.0 there, 6.0 over there, 6.7 up here in the northern, near Waikoloa. Beautiful place. I'm sure some of you have been there or live there. So that broadly shows this lithospheric flexing that the USGS is talking about. And this box, by the way, I drew around the islands is actually quite large. And so you're not seeing that sort of lithospheric stress and earthquakes occur, let's say, over here or over there or over there. Now, there are going to be other earthquakes, but they're going to be lower magnitude. This is magnitude 6 or greater for this time frame. And if you look at the biggest one, 7.7, 1975, that was a big deal. And right behind it, just recently, less than a decade ago, same location, almost exactly magnitude 6.9. And that occurred one day after the rift eruption began, Leilani Estates. So, in terms of this earthquake, it was about 15 to 20 plus seconds of shaking. The main reports I received were that it was quite intense. So pretty big sudden jolt hit people. And some people were shaken up afterwards. Things are falling off the walls. Things are breaking as a result. But in terms of damage to buildings, I haven't seen really too many reports of that. We can look at the shaking of this earthquake right here, in fact. So check this out. This is interesting. Here we see a live stream from the summit of Mauna Kea. Here we see all the observatories, performing their astronomical observations. And this is about 20 seconds of shaking that was recorded from this earthquake at Mauna Kea. So 15 to 20 seconds of solid ground motion, but it wasn't enough to be super, super destructive. And in general, for you to really start to have buildings coming down, you need there to be really high amplitude surface waves. We can keep that on actually. High amplitude surface waves. And with Hawaii being volcanic, you don't have these sedimentary rocks or these sedimentary layers that really amplify these energies. So that's a good thing. Volcanic rocks in general, they have a high shear wave velocity, and so that seismic wave is able to basically punch through them and just propagate out very quickly. It's when you have low shear wave velocities that the surface waves are really strong. So that doesn't mean you can't have destructive earthquakes on Hawaii. A 6.9, a 7.7, a 7.9 is going to be destructive. Or some of these areas here are a bit more sedimentary. You get a magnitude 6 in there, it's going to be a different story. But thankfully, this is right on the slopes, effectively. People living here are living right on the slopes of Mauna Loa. And as a result, yeah, there's going to be shaking, but there's probably not too many buildings that suffered damage as a result of this, thankfully. Whereas the magnitude 6, for reference, that occurred in Napa 2014, that's in a sedimentary filled in volcanic caldera, especially right near the river, the Napa River. That it was shaking for a long time, and you had like $1 billion plus of damage. So it shows you how the regional geology and the actual properties of the Earth and how they vary across locations influences the final take-home results of an Earth event like this. But something is stirring underneath the Big Island. There's some interesting research that we can look at. Just quickly before that, because we're still talking about this lithospheric loading and stressing, just kind of want to show you the bathymetry data for this. So here we see the Big Island, of course, the main Hawaiian islands here, and then you start to see the seamounts. Okay, so they erode, they sink below, but this is one of Earth's tallest mountains, effectively, right? Going all the way from the bottom here, and if we get our elevation, 5,500 meters below surface, right? That's like about 1,600 feet, a little bit more. 1,600 feet down, like 3 miles down, right? And then you go all the way to the highest, and we'll choose Mauna Loa there. 4,000 meters up, if you do Mauna Kea, just kind of roughly, let's see what that comes at, 4,000 meters up. So it's a huge, huge swing. And look at the width on the Big Island, right? Or you also look here with the full complex going from Maui to Oahu, right? This is really one larger island now that has submerged quite a bit, but we have now the surface expression of multiple islands. These are big forces on the plate. Interesting thing to note though, is if we go back, again, I drew this box for the big earthquakes, magnitude 6 or greater, across like this whole big area to try to catch any oddballs that may pop up, is you don't see that lithospheric flexing, these earthquakes due to lithospheric flexing or whatever, so much with this larger block there. Now, a lot of it's submerged, so the overall size of the big island, because it is so high vertically now, would make a difference. But I do find that a little odd. We do have this magnitude 5.6 here. Actually, this is magnitude 5.5s and graders. Magnitude 5.6 there, 1979. And we do have some earthquakes here around Maui, 6.6 in 1938. So Maui can get bigger earthquakes too, but we don't see any for Oahu or Kauai or Niihau, and some of these others, they're not showing that anymore as well. So yeah, there's this weight bearing aspect. There's something to that for sure, but I think also because again, this was like the reverse thrust. I mean, it could be related to some hotspot process that's unfolding right now. It's certainly very possible. And actually, before I get to some of the other data I want to present, I just want to quickly show you the star chart for this, because the ancient Hawaiians were very interested in what was happening in the sky and astronomy and more. This is a true sky astronomical chart. So these are the constellations as they are in the sky, true to size, and where the planets and the sun and more were at that time. I already plugged it in. And we see here that this occurred exactly during a Uranus Cazimi, because we had Uranus Cazimi yesterday. What is a Uranus Cazimi? Well, Cazimi is just the term that we use for when there is a planet that's conjunct the sun. When you have something conjunct the sun, it's called a Cazimi, C-A-Z-I-M-I. And that's a powerful moment as it relates to the alignment, but if we bring in a little bit of astrology, there's deep wisdom there, right? It's the oldest science. Whether you think it's science or not, it is technically the first science that we had, which was astrology. They used to be one and the same. Astrology, astronomy, they've diverged apart. True sky, this stuff is, kind of bringing it together. But that's a powerful event. And look at where it occurred. It's Uranus, and Uranus represents these sudden shakes and changes, and it's also connected into earthquakes. Uranus is a planet associated with earthquakes, and it occurred in the constellation of Taurus, which is known as solid Earth, like fixed Earth. The Earth itself, that's what Taurus represents. It's the bull, the constellation of the bull. Whereas, for example, Leo there is the constellation of the sun, right? We're not seeing it happen in Leo. We're seeing it happen, the Uranus Cazimi, in Taurus on the Pleiades, the star cluster, which the Hawaiians have a whole history with. So very interesting that you get this magnitude 6 right on that. And then directly below the Earth, when this occurred, you had Saturn and Neptune in Pisces, which is the ocean. Saturn also being connected to the structure and flow and movement and sudden breaks and changes. Uranus being this dissolving agent, being also connected into the archetype of the ocean and more. And this was occurring directly below the ground, the IC, effectively. Whereas this would have been the top of the sky when this occurred. That's Virgo. So at that time at night, if you looked up, you'd be seeing the constellation Virgo. And they have good skies there, so you would see that. You would see the moon there, quarter moon. Right now it's about quarter moon. We see this square between the sun, Uranus, and the moon. So it's halfway to its full moon, going this way. It'll be in Ophiuchus and Scorpio coming up. These were exactly below the Earth, imprinting their energy to the Earth, right in line with the Hawaiian hotspot. So just, a little something, take what you want from that. I just find that I study into this and it constantly reaffirms itself. Really cool stuff. Okay, but here's what I want to show you. And we got some data to go through. I had just recently been reading about volcanic cycles and their rhythms on Earth globally. And there is this rhythm that you can identify in volcanic records and eruptions of basically 9.5 to 11.5 years. And what we know, the solar cycle is on average about 11 years in length. It ranges from 7 to 17. This is the magnetic flip of the sun, right? And you have periods of high activity, solar maximum, periods of low activity, solar minimum. But the solar cycle is on average about 11 years. So the fact that people have found this 11-year cycle in volcanic records and other records is like, okay, like, is this from the sun? Because the sun could very well be that causal agent. If anything's going to be a causal agent, it's going to be the sun. So I was like, well, let's take the earthquake data that we have for Hawaii, magnitudes 5.5 and greater, and do a power spectral density plot for it and see what wavelengths pop out. Well, we get this volcanic magmatic load cycle, which has been identified by the USGS. It lasts about 31.6 years. So every 30 years or so, every 32 years, there seems to be, there's definitely a heightened risk of volcanic activity. The last peak for this was 2018 with Leilani Estates, a magnitude 6.9. Now here we're looking at earthquakes, right? This isn't volcanic activity. We're looking at earthquake rhythms here. But that does line up with 2019. And then you wind it back and it takes you to, I believe it's 1989, which is also, the last peak for this volcanic magmatic loading cycle was 1989, which is when you were in the Pu'u'o'o eruptive cycle, and there was a magnitude 6.2, June 25th, 1989, and you also had a high volume effusion from an expansion of the Kilauea East Rift Zone at that time. So this is a very important cycle that demonstrates itself via earthquake activity, especially bigger earthquakes, okay? So we're starting to come down from this magmatic loading cycle that's about 32 years in length. And well, interesting, you do 11 times 3, you get 33 years. That is a resonance of also a solar cycle. And in fact, if you do 10.5 years times 3, well, that's 31.5. Okay, so this other cycle popped out. I was like, boom, there it is. I knew it would show up. That's the solar cycle. We have this 10.5 year rhythm pop out. And once you start to get to these higher frequencies, you especially get a lot of noise at the 1 to 2 to 3 year zone. So this right here is showing up as like a 5.5 year cycle. So there may be something to that one as well. Of course, that's also an intermediate half of this. So you see these solar cycles manifest, and this is just the data for Hawaii, right? Just pull this up on USGS and you could do the analysis yourself and boom, there it is, okay? So what is it? Well, also checked out the power spectral density for magnitude 4 or greater earthquakes for 1904 to 2026. I guess we didn't have any for 1900 to 1904. And keep in mind, we've detected a lot more magnitude 4 and greater earthquakes with newer equipment more recently. So the record is going to be pretty limited early on. But you can do a power spectral density for that as well. And that magmatic volcanic loading cycle does disappear once you include all these new magnitude 4s, because that's, magnitude 5.5 is probably a good place to select that, to really choose the highest, most impactful events. But we do see these cycles that are on both sides of that magmatic cycle, which is 20.4 years, 40.9, but that 11-year cycle pops out here very clearly as well. And that's probably in some aspect, the most distinct peak, because that one we very clearly know is exactly in resonance with that solar cycle. So then I created a plot for this showing the actual sunspot numbers going back to solar cycle 19 and earthquake counts for magnitude 4.5 and greater earthquakes. and also an idealized earthquake rhythm, because the last, we had these, variations in earthquakes across time. We see that there was a big pulse of activity right here in 2018, 2019, because, well, that was the end of the Pu'u'o'o eruptive cycle, and we had the 6.9. You're going to get aftershocks from that. Look at that. For earthquakes magnitude 4.5 and greater, there were like 70 earthquakes that year, which is crazy. That's 2018. And look at that. It's right as you start to go to solar minimum. So, and right now we're at the, we're getting close, we're at the very end of solar maximum, the beginning of the descending phase. We're right in that zone. So we're not anywhere near solar minimum. We're still like 3 years away from solar minimum. So we had this. Well, if you track back, we also had late 2009 and late 1996 as these other zones. So I wanted to plot this data out. And if we go back to this solar minimum, we see in general higher earthquake activity around the low period versus lower activity around the high period of solar activity. Again, this is logarithmic right here. So that one is quite a bit different than, let's say, 6 or 7 events right there. So, make sure you're reading this with that in mind. But we clearly see this trend. It's not perfect. It's not perfect idealized like we have here. This idealized rhythm is exactly because it's idealized. But we do see this trend where activity for earthquakes at Hawaii increases during solar minimum versus during solar maximum. And that was very clearly evident with the last solar minimum. And this goes back in time too. We see here in 75, remember that magnitude 7.7, 1975? Look, that also shows up very clearly here. And we see in general that when solar activity is lower, that earthquake activity is higher. So we are right now in a bottom of a Gleisberg cycle. These are about 80 to 100 year long rhythms of solar activity, whereas you have the normal 11-year cycle like this. Low, high, low, high, low, high. You also have this like 90-year-long variation effectively. There's a bit of variances, but 80 to 100 years. This is that cycle. Last time we had it was the early 1900s, so it's been about 100 years. Solar cycle 24 was quite weak, and look at how we had this big spike of activity after solar cycle 24 during the minimum and also during the bottom of this Gleisberg cycle, which we are still effectively in right now. We're definitely not near the peak of a Gleisberg cycle. That's going to be like 2060 or so, 2060, 2070. We'll look at solar cycle 20 here. You had solar cycle 20 coming in quite a bit weaker than 23, 22, 21. 19 was the strongest in solar cycle 3, okay? 20 was like this oddball, pretty similar to these two, right? Well, you had the magnitude 7.7 follow up during the solar minimum of solar cycle 20, like afterwards. So that's an interesting connection there. So it's not exactly perfect. The idealized rhythm is perfect. This earthquake record and the anti-correlation between, it's not like you have high earthquake activity during high sunspot activity. It's the opposite. It's not exactly perfect, but it clearly demonstrates itself as you look across. So I wanted to present that to you because what that indicates is two things. We did have this big volcanic magmatic pulse wave, this rhythm that's about 30 years in length, peak back in 2018, 2019. So 2017 to 2019. So we're starting to come down from that. So it's 2026 right now. So in about 22 years, 2048, I guess, is when we can expect perhaps volcanic activity to be quiet in Hawaii. But we're still pretty, we're still closer to the peak of that magmatic pulse, that 30-year rhythm, than the trough. So we do have that, but we also have this shorter-term solar rhythm that will be likely increasing volcanic activity for 2029, 2030, 2031. And that will bring in probably more earthquakes as well, because the two are connected. When you get these big pushes of magma, it generates earthquakes, and the biggest earthquakes on Hawaii have all been connected to volcanic activity. It wasn't flexure of the crust or anything. It was volcanic. And as Puna Rebel here is saying, this ain't nothing, folks. 2018 was something. Yeah, exactly. So if you're living on the Big Island and you felt that, you know that I wasn't there, but yeah, you know it's something. So some of these people are like, they're like, wake me up when it's a magnitude 10. It's like, are you stupid? For the magnitude 9.5 that struck Chile in 1960, actually the anniversary I believe is today, May 23rd. Magnitude 9.5. It was 10 minutes of ultra intense ground, like extreme ground shaking. 10 minutes near that epicenter. Or Alaska, 1964, the magnitude 9.2. Also, many, many minutes of extreme ground shaking. So, you know, there's no record of a magnitude 10 ever happening. Some of these, you know, if you've never lived through one of these things, everything is fake news or nothing burger, nothing ever happens, whatever. I'm tired of it. You know, when you wake up to 20 seconds of shaking, intense jolts, and things are crashing down around your house, yeah, that's a big deal. So thankfully this magnitude 6 being only a magnitude 6, that's kind of the point that I'm driving to. Thankfully, just a magnitude 6, it could have been quite a bit worse. So we're thankful that it was only a magnitude 6. But we could get more, and I think rather than this, and now there's a chance that this is a foreshock for something bigger, but I think that's a very low risk in general, but always good to be prepared, to be mindful of this. I wouldn't live in fear of it, but good to be mindful. The bigger thing that I'm seeing is just how we probably have a pretty big volcanic wave coming in, because we've been seeing all this activity at Kilauea. 47 eruptive episodes now. The 48th eruptive episode is slated to begin in just a few days. That will have, as I mentioned earlier in the video, that will have broken the record for lava fountain episodes as compared to the Pu'u'o'o eruptive cycle, 1983 to 86, but actually the full cycle was 35 years long, from 83 to 2018. That was the biggest eruptive cycle from Kilauea in 200 plus years. Some people say 500 plus years. And we did it twice as fast with pretty comparable lava fountains in the Halemaumau crater. So if this is the beginning of a longer cycle, and this is a super cycle of volcanic activity, like a 500-year-long super cycle of activity, let's say, things could really heat up. This could just be the first foray into some really big eruptions that could be very destructive, because they can pop out in different locations. Right now they're popping out just in Kilauea, right in the crater. I'll show you. Right now they're popping out just here in the Halemaumau crater, right? But you have these rift zones all over. You get them popping out back in Leilani, perhaps. All along the south flank of Kilauea, down here southwestern side. Mauna Loa could wake up. Again, the Pahala Sill complex is connected to both of them. And the shock wave moving through them likely activated all of them. The question is this volcanic plumbing system, can it take that shock and basically just shrug it off? Or is it going to kind of trigger a chain reaction that something now needs to happen? Maybe any excess pressure that occurs will discharge with this next eruption at Kilauea. It's possible that shifts the rhythm at Kilauea too. If we go to our monitoring data here, we see the rhythms have been getting shorter and only about 9 hours in duration. And the lava fountains have been like 600, 700 feet. And that's quite a marked change from these big, super long eruptions with really big fountains, higher volume with big recharges in between. It's definitely shortened up, but maybe this is the signal that helps buck the trend and get it on a new rhythm of bigger eruptions. Or maybe it shifts the movement of magma somewhere else. These are all distinct possibilities that we can't just immediately ignore or discount. Okay? Now I don't think you should sit here and ruminate on all the different things that can occur, right? Because yeah, I mean, a meteor could hit Earth and kill us all tomorrow. So like, rumination's not good. But if you live here, then you should just be aware of this possibility. You should always be prepared in general and live your life. So this is your update for you on that big magnitude 6 striking the big island. And the fact that we did have this at this time, as I showed you with the data, we did have this near solar maximum beginning of the descending phase, right? This is that earthquake right there. Means that we could be looking at a pretty big upsurge in earthquake and volcanic activity during the next solar minimum, which is around 2029 to 2032 or so. We'll see. That's basically going to be bang on when it occurs. So yeah, we probably have a lot more coming from Hawaii in the next few years. That at least would be my base case forecast. Of course, there's many possibilities that exist in life and reality, but that would be my majority forecast. And I would say, you know, this eruptive episode cycle at Kilauea just totally closing up and everything goes quiet for the next 5-10 years. I don't think that's a probability over 50%. Maybe it's like a 20-30%. I don't know enough about this to give a good clear percentage on that, but just in general broad strokes, I think we're much more likely to have bigger volcanic activity going forward for the next decade for Hawaii rather than less. Because there is a lot of evidence. There's way more evidence that we're in a volcanic supercycle than we are not in a period of heightened activity. I mean, 2018, clear example. The Pu'u'o'o eruptive cycle, clear example of this. We are in a volcanic supercycle. The question is it even building faster or is it decaying? And well, the fact that we've had these 47 lava fountain episodes at Kilauea nearly twice as fast as what occurred at the beginning of the Pu'u'o'o eruptive cycle isn't the best data point, right? There's this distinction between winning battles and winning wars, right? Maybe that's one win for the volcanic battle, but the actual war means that volcanic activity will go down, if you understand the metaphor. But it's definitely not a good data point, right? If Kilauea stayed quiet instead, that'd be a little bit more indicating that maybe things are quieting down, obviously. That's not what we're seeing. We're seeing things pick up. And now this magnitude 6, further confirmation of that, maybe related to you know, deeper mantle. Doesn't have to be magma. It could just be, you know, kind of pressure from the mantle pushing up, because again, it was that reverse thrust fault. It was oblique, but still it was a compressional reverse thrusting event rather than extensional, which you think would occur with the weight bearing down, causing the crust to expand out a little bit to accommodate that. So it could be a bit of, you know, just pressure from the mantle coming up, not necessarily magma, but the mantle is a bit more fluid, the asthenosphere effectively. We don't exactly know, but this is everything that's happening. So wanted to keep you up to date on all of that. I'll see if there's any questions or anything that have come in. There's one question that's not really on topic. Geraldine, thank you. I'll pack a go bag. Just in general, I think that's a good idea to do. Anywhere you live, everywhere has natural disasters. It's good to just be aware. It's good to be prepared. So thank you so much for that very generous super thanks. And kind of unrelated, but I'll answer it. Thank you, Gaia, for the super thanks all the way from Turkey. How can we merge with our most abundant timeline with the abundance of source? Namaste, thank you so much. Well, just in general, and I'm no expert, but just, you know, live your life, follow your passions. That may still mean you have a day job, but, you know, if there's something that you really enjoy that lights up your soul, I think if you're in that resonance, you're doing the things, you're in that resonance, everything else aligns. And it's not this, doesn't have to be this crazy equation where you have to overthink everything. Just like pursue pursue the things that, really light up your spirit in a way that also ideally help others. Because I think that's where the magic is. So I think so long as, and this is a personal belief of mine, I think what we see is you have the Earth, and Earth events literally reflect what's actually happening with people and the planet at like the surface level. So, this part of the world is always going to be an area with big geologic shifts just because of the very nature of it. And the energy on the Big Island and all of Hawaii, but the Big Island is really incredible. I mean, you can feel it there. There is a magic energy that exists. Like, people don't talk about the ancient Hawaiian gods as just these caricatures or something. Like, they are living, conscious beings that exist. Like Goddess Pele, the lava gods, like people talk about are not like a joke or something. It's like, no, Pele's angry today, let's say, right? It's taken very seriously. As in general, this understanding reality has for like 99% of our history, right? Thousands of years, people understood this. It's only in the past like 150 years really that we've become really disconnected from all this. I think kind of purposely some people, have pushed for that, especially established religion has pushed for you to be disconnected from source, and instead they want you focused on, some fake narrative or whatever. So, the people of Hawaii, they are undergoing a big energetic transformation. They're experiencing a lot, and it'll be very interesting to see what happens for the island and for them in general. I'm very, very hopeful and optimistic. It's, one place on the world that's growing. The Big Island is growing. It's incredibly lush, fertile, but there are, consequences to that with these eruptions at times, but they're also incredibly resilient. Tons of off-grid communities there, green energy production, rainwater collection, people in tune with the environment. It's really incredible and beautiful to see, and it gives me hope for humanity. So I'll leave you with that. Thank you all so much for watching. Wishing you all well, especially those on the Big Island, Hawaii, and all across the islands. I hope you are feeling good and okay. I'm not super concerned about the immediate future in terms of some sort of big event, but it's certainly possible, like bigger earthquake, it's certainly possible. So I think it's probably just a magnitude 6, but just keep that in mind. I'm more concerned about the volcanic activity going forward, it increasing intensity, volume, duration, and destruction. That's not guaranteed. It's certainly possible though, and it would be my default forecast. And one last thing to show you, just because this is kind of wild, because I just made this clip video yesterday on this, 8.5 minutes. I'll link that in the video description. But I did just before this earthquake popped off. Where is it? Is this it? No, where is it? I had this post here on X. I quoted the USGS Volcanoes Twitter account and just said, watch Hawaii. And then, 24 hours later, magnitude 6. So I wasn't saying watch Hawaii for that. I was saying watch Hawaii in general for just activity. But the other aspect to that story was that when I was sleeping this morning, I had this dream about earthquake, and I was like, yeah, maybe I should get up and check to see if there was one, because I kind of had this nagging sense that something had happened and I should, jump on it right away. Well, when I did wake up, I checked my phone and my dad sent me a message saying, big earthquake Hawaii. It's like, I was right, I knew it. So spirit and universe work in very interesting ways. That is what I'll leave it to. So thank you all. Have a great day. See you soon. Enjoy your Memorial Day weekend, and I'll be back with more content for you in the meantime. Have a great day.